What's up, everybody, and welcome back to another video on SAT Math from the Scalar Learning channel. And today is a very important video because this pertains to the digital SAT and the fact that the entire SAT now allows for a calculator. But more importantly, it allows you to use the DESMOS embedded calculator, which is embedded in the Blue Book app, which is so amazing. I love DESMOS. I'm so happy that you get to use it. I've been using it for years with my students. So this is a huge benefit. So I'm going to go through and show you, based on different categories of question types, how to use DESMOS super effectively, different ways to use it. And in some of these cases, you can still solve it by hand algebraically, which is totally fine. I'm just going to show you another way, an alternative way to solve it strictly using the calculator. And this can be used as your primary means or also just to check your work at the end of the test. Let's do it. By the way, just a quick note, if you guys are looking for the best digital SAT resource on the market, check out the SAT Crash Course. That's down below. Use the code SCALAR for 20% off. I highly recommend it. The best way to prep for this test is to do as much good, solid practice as possible. And this is the place to get those practice tests. Plus, there are video explanations for every single math problem and every single available practice test that is administered from yours truly, myself, okay? And so it's me teaching and explaining the math in the best and most efficient way possible. So check it out. So for this one, this is under the first category, solving linear equations and inequalities. You see we have this equation and they're saying which equation has the same solution. So of course you could do your typical isolation, -6 divided by 4, or you can do this. You can plug it in to DESMOS. Now, I don't like to plug in equations as is. Instead, what I like to do is I plug in the left side as one thing. I plug in the right side as the other, as two separate equations, almost like a system of equations. You don't need the y for the first one, but I'm just putting it in. And then you see where they intersect, and that is at 3, right? We're solving for the x value. Now, if you did just put it in as is, you'll still get the same thing. It's just sometimes a little tougher to see, right, what this line is, that it is 3, but it's just that x value. So anyways, now we know x equals 3. But the other thing is they said which one has the same solution. What you can do is, without even looking at this, you're basically, and finding that value, you're basically plugging in the option, seeing which one lines up. So check this out. We have 4x equals 108. Nope. 4x equals 24. Nope. 4x equals 12. Boom, there it is. That's how you do it. C is the winner. Done. Next, we have another example. 4x plus 5 equals 165. Again, you could say 4x plus 5, and you could say 165. Now we're going to have to look for that x value, and here it is. It's right at 40. So that's a quick shortcut. Again, you could also separate it out and say 4x plus 5 here, y equals 165, and then you'd have to scroll up and just find that intersection point right there. Either way, you get 40 for x. Done. Now we're at linear equation word problems. This one says the function is defined by this equation. What is the value of f of x when x equals 4? So one thing you can do is just simply put in the function 7x plus 2, and then they're saying x equals 4. Well, I can just replace that x with 4, and look at that. It evaluates right there in DESMOS. The answer is 30. That's how you do it. Done. For this one, which falls under the category of linear relationship word problems, okay, we're trying to figure out which one of these matches this graph. So watch what I'm going to do, right? There's multiple ways to do this, but I'm going to kind of line it up so the graph looks kind of similar, right? It's going to a max of 40 down to 100. And I could change the settings to make it look even better, but this should be good enough, right? I'm seeing a y-intercept of 40, an x-intercept of 60. Now I'm going to try these different options. So check it out. Y equals 8x plus 12. That's totally wrong, right? It has a positive slope as well. We've also got 8x plus 12y equals 480. That's actually looking pretty good. Now, check this out. Y-intercept of 40, x-intercept of 60. We can stop there, but we're going to show you the rest of these. Now, again, I'm going to skip C because it's got that positive slope that's going to go in the wrong direction. Now, let's look at D. We've got 12x plus 8y equals 480. And again, it's pretty good, except for the y and x-intercept are flipped, right? You see it hits at 60 and 40 as opposed to 40 and 60. So anyways, B is the winner. Done. Now we're solving systems of linear equations. Again, that's two linear equations. We're trying to figure out the value of x or y. Here, we're trying to figure out the value of x. Watch how nice and easy this is. You could do this, again, algebraically with some substitution, but instead, I'm just going to plug them in like so. 4x plus y equals 15, and we're going to look at that intersection point. That's the solution, right? And they want the x value, not the y value. The y value is negative 45. The x value is 15. Just for fun, if you want to plug in and check, if I plug in 15 for x, I get negative 45. That works. If I plug in it here, I get 60 plus y equals 15. Y would again equal negative 45. That confirms C is the winner. Done. Now this one is a systems of linear equations word problems. It's a little bit trickier. If you look at the answer choices, they've got this weird constant in here called r. Now I'm going to show you how to do this really nicely, okay? So we're going to have 2x plus 3y equals 7. And then we've got 10x plus 15y equals 35. So what you're going to notice is the top function and the bottom function, they're right on top of each other. They overlap. So really, when we're trying to find a point, we're trying to find one of these points is going to be on both of them, aka either one, right? So you might look at this and be confused by the r, but this is really cool, okay? R can be anything. They say r can be any real number. So what I can start to do is I can start to plug in these different options. So we got r over 5 plus 7, and you see this little option for a slider. We're going to click yes. And I'm going to show you what that does in a second. But then we've got negative r over 5 plus 35, okay? And so we've got this point. Now, I put in 1 for r. That's totally allowed because it says r can be anything, right? R can be any real number. So why not set it to 1 or set it to 2 or set it to 3? So at this point, I've got r equals 3. Here's my coordinate. It's not on the line, so I can cross off a. Now let's try b. Now look at b. That looks like it's right on the line. This is probably a winner, and that's at negative 1, 3. What we could do with this, since I know that's negative 1, 3, I can even plug those points in, right? Negative 1 times 2 is negative 2 plus 9 is indeed 7. Negative 1 times 10 is negative 10 plus 45 is indeed 35. So that's verification right there that B is the winner. You can go through and check the rest of the options, but you see how nice and beautiful this is when you can plug it straight into Desmos. So that's how you do it. Done. Now we get a graph of linear systems and inequalities. These are two inequalities. Straight away, I'm going to plug it in, right? So I'm going to show you what the graph looks like of y is greater than 14 and 4x plus y is less than 18. It's really nice. You don't have to isolate y. You can just put it in as is. And the system of inequalities, we're looking for the shaded region, okay? The double shaded region. That's our solution set. So now they say the point x53 is a solution to the system. Which of the following could be the value of x? So let's just run down the line, right? We could have negative 953. We're starting at the top, right? Is this in our solution set? No, because it's on, oh wait, yes it is. Negative 953, it's right in there. So there you go, there's proof positive. We know that that is the winner, but let's go through the rest of them just so we can debunk them. Negative 5, boom, it's not in the double shaded. Obviously, as we go more to the right, 5 would be out and 9 would be out of the zone. So anyways, that confirms it. A is the winner, done. Now we're getting into percentages. What is 10% of 470? This is just a straight up calculator problem. Just remembering to convert 10% to its decimal equivalent of 0.1, and that word of essentially signifies multiplication. So 0.1 times 470, there you got it. 47 is the winner, done. Now this is an interesting one. It says the number A is 110% greater than the number B, and the number B is 90% less than 47. So first, let's figure this out, right? B is equal to. Now we can put in the 90% less than 47. So if we're saying 90% less than 47, first I want to know what is 90% of 47. That's 0.9 times 47. And then 90% less, so I'd be saying 47 minus that quantity. And we get 4.7. Great. Then this is B, by the way, right? So then we go down to A. That means A is equal to 110% greater than number B. Again, that's not 110% of B. That's 110% greater than B. So that's converting it to its decimal equivalent 1.1 times B, right? Plus the original B value, which is 9.87. That's how you do it. Done. Now, this one is asking about the median of the data shown. Now, you might know, hey, median, you organize from least to greatest, which this is organized from least to greatest, and you find the middle value. And that's fine, but you might forget it, okay? And if you do forget it, there's an amazing function, right? And so we can see that here, but if you do forget it, there's an amazing function that we can employ. Is literally median. You type in the word median, and you lay out the values, right? 73, 74, 75, 77, 79. The order doesn't even matter, by the way. You can put them in out of order. 82, 84, 85, and 91. Just make sure you don't have a typo. But then again, that verifies what we predicted. 79 is the winner. Done. Now again, just like we saw with median, there's also a mean function. Now you may say, well, I can just add them up and divide by the number that there are. Well, you can do that. You can add them up, divide by 10. You can also do this, right? We got 6, 8, 16, 4, 17, 26, 8, 5, 5, 5. And again, you have to be very careful you don't make a typo, but assuming we got them all in there correctly, there it is, 10. Now just for fun, let's add them up mentally and see what we get. 6 plus 8 is 14, plus that is 30, 34, 44, 51, 61, 71, 77, 85, 90, 95, 100. 100 divided by 10 is 10. Boom, done. So for this one, we're trying to find an equation that is the most appropriate linear model for the data shown. Now, this is great because, again, we can just plot these functions and see which one matches that pattern. Now, you might look at this and say, wait a minute, that's a negative slope. So C and D, those have positive slopes. We're not even going to go there. And that's fine. And that's great if you recognize that. I'm going to go straight to the gold, which is what I know is correct, which is B. And I'm going to show you what that looks like. Again, we can say y equals, or you can omit the y equals. Let's put it in. Y equals negative 1.9x plus 10.1. That looks really, really good. But let's put in option A as well, just so you can see the difference. It's almost the same thing, it's just minus here. And there's option A, right? And that makes sense. It's got the wrong y-intercept, negative 10.1. So anyways, that confirms it. B is the winner. Done. Now for this one, you can do a nifty little trick, right? You may know, hey, the denominator is the index of the root, the numerator is the power. You can break it up that way and then try and equate it to these. Or you can do this, right? You can say a to the 11 over 12. And now we can add that little slider that we talked about, right? Let's not make it 1 because 1 gives us some weird false positives. Let me get 2. So 2 to the 11/12 is this crazy number, right? Whatever. So now we're trying to see which one of these gives me that same value. So we can write it in radical form, or just to make it easier, I'm going to convert it to exponential form. Again, the power is the numerator, so that's 132. That index is the denominator, which is 12. So obviously that's A is totally not right, which makes sense. Next we got 132 and 144. Ooh, look at that. Those match up. So I already know B is probably the answer, but let's keep going. Then this one is 132 over 121, which is not correct, but close. And then last one is 132 over 11, which is going to be way off, right? 4,096. So anyways, that confirms it. B is the winner. Done. Now for this one as well, if you know your exponent rules, when you multiply the same bases, you add the exponents, and that's fine. And this can be pretty straightforward. But if you happen to forget it, watch how I'm going to do it in DESMOS. I'm just going to put in that first expression, right? M to the 4th, Q to the 4th, and Z to the -1, right? And this is all multiplied by MQ to the 5th, Z to the 3rd, okay? So we got that, and now we'll just put in our sliders. Again, I just don't like 1, but we can make it 2, we can make it 3, and we can make it 4. These are arbitrary, but it doesn't matter, okay? Just making them 2, 3, and 4. It does say they're positive, so that helps. Okay, so now we got this crazy number, whatever. It doesn't matter what it is. And by the way, what I'm going to do here, just to save a little bit of time, instead of typing them in over and over, I know what the answer is, right? M to the 4th times M to the 1st is M to the 5th. Q to the 4th times Q to the 5th is Q to the 9th. -1 plus 3 is 2. So I know my answer is B. So let me show you what's going to happen when we plug in B. We got M to the 5th. We've got Q to the 9th. And we've got Z to the 2nd, okay? And check it out. We get that nice, amazing number that we got up top verbatim. So there you go. That's how you can do it. Done. So once again, we have this expression. We're trying to find an equivalent expression, in particular, an equivalent rational expression. So you could simplify, you could factor on top, you could cancel out and find the simplified version, or we can use DESMOS to our advantage. Now, instead of using X, which you can totally use X if you want. You can use X, you can create a graph, and then you can compare the graphs and see which one matches. But I'm going to replace X with C, and I'm going to set C equal to 8. It says X has to be greater than 7, so we're going to go with 8, right? So watch this. 8C times C minus 7 minus 3 times C minus 7, and this is all going to be over 2C minus 14, okay? We're going to add a slider. As I mentioned, we're going to set it equal to 8. You don't have to drag it, by the way. You can just go bop like that and make it 8. All right, now we get a value of 30.5. Now what we're going to do is we're going to go through these, plugging in 8 for X. What we're going to do in DESMOS, and we're going to see which one matches with 30.5. So just looking at A, I can dismiss A because 8 minus 7 is 1. 1 over 5 is not 30.5. All right, let's check out B. So we have 8C minus 3 divided by 2. And look at that. We got 30.5. And that's your winning answer. Now, you could, again, factor out the X minus 7. And then you got X minus 7 times 8X minus 3. Factor out the 2. Cancel. Do all that stuff. And B is indeed the simplified version. But this cut through all the work. That's a great way to do it. done. Now for this nonlinear function, I'm going to show you a nifty way to do this as well. But when I type it in Desmos, I'm not going to use n, I'm going to use x. The reason why is because I want this as a nice actual function that shows up as a graph. So on the right-hand side, or for one of these, it's 7x cubed. And we're trying to figure out when this is going to equal 56. And the function value is almost equivalent to y. So what I'm going to do is I'm going to say y equals 56, and we're going to look for that intersection point. We're trying to find n, which in our case here on the Desmos graph is x. All right, so where's y equals 56 is right here. What's the intersection point? Boom, when x equals 2. That means 2 is the winner. You can verify by plugging it in. 2 cubed is 8. 8 times 7 is 56. That's how you do it. Done. The function g is defined by this for which value of x is g of x equal to 25. Again, this is a great opportunity. I can just plug and chug, right? We got x squared plus 9. That's my function. And I want to know when the function value, aka y, equals 25. So now we're going to look for that nice intersection point, and we see it here when x is 4. That's how you do it. Now, once again, just to go back to that original point, I could write this in as x squared plus 9 equals 25. And then you're getting this value, you're getting it like this, right? You're seeing my 2 points, -4 and 4. Just remember, it sometimes is a little funky when you click on the line, or you might be confused, why am I getting a line? But you're looking again for the x value because that's what we're solving for. So 4, technically -4, oops, -4 also works, but 4 is the one they have here, so that's the winner. Done. Now for this one, we got this nice quadratic. Again, I'm going to use x instead of z, so it actually shows up like this, x squared plus 10x minus 24. Now, when we're saying when does it equal 0, I can just look at these intercepts. I got 2 and -12, and it says one of the solutions. It can be either 2 or -12. Or, again, we can set it equal to 0, and we get those values as well, 2 and -12. Either works. That's how you do it. Done. Now for this one, linear and quadratic systems, it says we've got this equation, which is a quadratic, intersecting this line at exactly 1 point. What is the value of c? So really what we're talking about is substituting and then using the discriminant and setting that value equal to 0, because that's when we get one solution. Or we can do something a little niftier if you forget that with this nice Desmos calculator here. So we got -x squared. I'm going to plug it in, plus 9. Okay, so now we got the slider in there, and now we've got different values that we're going to test out for c. Okay, so first is -481 over 4. So we're going to see, nope, it went too low, right? We got 2 solutions, so that's out. Next, we're going to try -100. Nope, we still got 2 solutions. Next, we're going to try -319 divided by 4. That seems to be the winner, right? Look at that. It looks like we got an exact solution, an exact one intersection right at the vertex, so it's probably C. But just to double check, let's check -9 over 2. And this one, where is that? Yep, that's no solution. So anyways, C is confirmed. Done. Now we got an absolute value equation. So we're trying to figure out 4x minus 4 equals 112. What is the positive value of x minus 1? All right. So we're going to plug it in like this. 4 times x minus 4, boom. This is my absolute value equation. And then I'm going to plug in on the other side, y equals 112. So this is going to help us solve for x, right? We're going to look for the intersection of this. And we got 2 possible values for x. We got 29 and we've got -27. Now, if they want the positive value of x minus 1, the -27, that's going to net me a negative value. So we know we're going with 29. 29 minus 1 is 28. 28 is the winner. Done. So for this one, when you read it very closely, right, it says the number of squirrels in a population was 150% more than the number in the population of the previous year. Okay, so we know it's increasing by 150%. That might lead you to think that it's either A or C, right? Because I see 1.5 that matches 150%, but the wording is very specific. It's not 150% of the previous year. It's 150% more. So imagine you have $100, and if you're getting 150% more, you're finding 150%, which is 150, and you're adding it to the original 100, meaning now you have $250. So that's actually 250% of your original. Meaning, and I'm just telling you this, but you don't have to do this if you're going to use Desmos, so I'm just telling you this, that means that actually A and C are out. It's going to be B or D. But how do we verify this, or how do we kind of use Desmos to flesh this out? So we know that at the end of 2016, we should have 180 squirrels in the population. And this is every year since 2015. So times 0 is 2015. When we plug in 1 for t, we should be getting 180. So check this out. I'm going to look at these different functions. Now, instead of plugging in x or n and t, I'm going to say y and x so that we actually get values, right? So I got y equals And let's skip A and C because I've kind of already eliminated them, but obviously you can check all of them when you're taking it, but let's cut them out for now. So let's go to B. Y equals 72 times 2.5, and then we're going to plug in, what was 2016 was 1, right? So we're going to plug in 1, okay? And check it out. We get 180. That's what we're supposed to get for 2016. So that verifies it, right? But just to double check, let's check out option D. It's the same thing, but we got 180 here. No, we get 450. So that's wrong. And that works out. So B is the winner. That's how you do it. Done. So for this one, we got a circle equation. How can we use Desmos with this nice circle equation? So we got diameters with these two endpoints. We got this equation. We're trying to find the value of R, which is our radius. Okay, so check this out. I'm going to put in these 2 points. We got 2, 4, and we've got 2, 14. And actually, wait a minute. This is actually pretty straightforward now that I think about it, because we can quickly calculate the diameter because these 2 points are right on top of each other. So we can find the distance between these two and then take half of that. That's the radius, right? That's what we're trying to find. That's R. But let's pretend we didn't even know that, all right? So now I'm going to put in this nice little function, x minus 2 squared plus y minus 9 squared is equal to r squared. And we don't know what r is, and that's what we're trying to solve for. And now we're going to add a slider for r. Now, again, if you're not familiar with the circle equation, and it doesn't matter if you aren't per se when you're using Desmos, because it shows you this exact correct circle, but this means that the center is at 2, 9. But that's where it's drawing it, right? Now, we want these endpoints to be on the circle. So when r is 1, clearly it's not on the circle. But now we can play around with this. Let's see what happens if it's 2. Nope. 3. Nope. 4. And I know I'm kind of assuming it's going to be a whole number, so you might have to tweak it if it's not. But assuming it is, check this out. We got 4, didn't work. 5, aha. It works, right? It's on. Now those endpoints are on the circle. That means radius is 5, which is what we predicted anyways. So that's how you do it. That's how you can solve a circle problem using Desmos. Done. That's it, guys. I hope you enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. And last but not least, if you haven't seen that link down at the bottom, make sure to click on it. Check out the SAT Crash Course, the best resource for studying for the digital SAT. Amazing practice tests, plus video explanations personally from me for every single problem on those digital practice tests available. It's the best way to learn with these problem walkthroughs. See how I do it, somebody who consistently busts out 800s on the math section. That's it for today. I wish you all the best of luck on your SAT math journey, and I will see you in the next video. Take it easy.